All right, everybody, we're continuing on there on page 7, and we will look at this one right here. The starts with 1/4 x minus 1 equals 2 minus 1/2 x. So a common denominator here would be 4, because 4 would be a multiple of both itself and of 2. So try to multiply by the LCD of 4. And I'm sticking the negative here onto the 1 before I multiply it and move on. And let's see here. And then that negative 1/2 x term will be the last one. And then we can do our simplifying. So we can divide these out. And this first term is actually just going to become x. Our next term will be negative 4. Then we'll have 8 and negative 2x. And if we add 2x to both sides, we can get all of the x's over here on the left, because that'll become 0. So over here we'll have 3x minus 4 equals 8. And then undo that subtraction by adding. And that will get us to the point where we have the x term by itself on one side. And on the other side will be the constants. And then our last step is to divide, which hopefully is a very common step at this point for you. So x would be 4 there. And it's always a good idea to go back and substitute these things into the original equation to double check your answer. So let's do that fast on this one so we can see that we did that and that we did get the correct one. So 1/4 times 4 over 1 minus 1, is that equal to 2 minus 1/2 times that 4? So 1/4 times 4 over 1 is 1, so 1 minus 1 on this side. This side is going to be 2 minus 2, so we get 0 equals 0. So yes, that x equals 4. Oops, sorry, there you couldn't see my whole check there. Yeah, so that's is the correct answer there. We proved it by finding we get a true statement if we plug it back into the original equation. And let's see here. Just check and see here. Okay, so we've got these last couple, and these are just bringing up some situations where you may have no solution, or you may have infinitely many solutions. So we may end up with one of those situations where we have a true statement, where all of our variables have disappeared, and that would be the infinitely many solution situation. Or I make it a false statement, in which case there's no solution, because I get down to something where it's like 5 equals 4, and that's not going to be true, so nothing we can put into the equation would make it true. All right, so let's start off with this one. So I'm going to get rid of my parentheses by distributing. So the left-hand side we're just going to leave alone for right now. And then collect like terms. So on the left side, these are not like terms, so we can't get this any more simple at this point. But on the right, we can collect these two constants together. So we get 5h plus 4. Okay. So at this point, I know what my answer is going to be, because I ended up with the same thing on both sides of the equation. Whatever I put in for h, if I have the same expression on each side of the equation, the two sides will always be the same. If you don't see it right away, then you can keep going. So subtract 4 from both sides to move the constants. That's going to get you 5h over 5h, or equals 5h, pardon me. And then we would subtract the 5h from both sides to get that moved over. So we end up actually getting 0 equals 0 at the bottom of this if we worked it all the way through. And this is a true statement all the time. So that means that it is infinitely many solutions. Because no matter what I put in up here, it really just means this. So it doesn't matter what I put in for h. I will always get both sides of the equation to be the same. Okay, let's try this next one here. Oh, I'm going to move my, I'm going to move this one, so I'll subtract 3y from both sides. Because there weren't any parentheses for me to do any distributing with, and the like terms were already collected, which is why I didn't do anything with those. So this will give me 0 minus 1, so this will be negative 1. And then over here, those will become 0, which is what I wanted, leaving me with a 1. All right, this right here, false statement. So never true. So equals no solution. So up until now, we've always given you, the we meaning in your homework and in books and things like that that we've looked at this semester, there's always been a solution. You haven't ended up in one of these situations before. So now you'll know that this is a possible situation where we could have it being true all the time or being true none of the time, leaving us to either infinitely many or no solution whatsoever. Typically we end up with a single answer there, but it doesn't happen there. Now we've kind of run across this one here on the right already because we had a situation very similar, but this one is actually going to give us a slightly different answer. And this would be one of those ones where it's a really good idea to know how to do this kind of a problem before the test. So I am going to move the 4x term. There weren't any things that I needed to distribute with parentheses, and there weren't any like terms to collect. So I'm going to go right to moving my variables onto all the same side. So I will subtract 4x from both sides. Over here, I'm going to get 0. And over here, I'm going to get 2x. All right. So looking at this, I want you to think about, okay, how do we undo this? So we're just following the typical rules that we do when we are solving. So we're just going to kind of see, where is this going to go? We haven't necessarily seen this situation before, but we know the rules that we typically follow will work. We just have to, we don't know exactly what the destination is going to look like this time. So we'll divide both sides by 2, and those will divide out. So we'll get x on the right, and then over here on the left, we're going to get 0. Now, normally, if we are doing a face-to-face class and I'm able to look at your work all the time, when I tell you that this is the one situation where you cannot show me work on an equation, solving an equation, if you remember what the logic of this is. So if you have a situation where you have a variable times a number and the same variable times a different number, but they are the same, they are set equal, so they have to be the same, then x has to be 0. That's the only way this works. For example, think about if you put 1 in here. Then you'd get 4 on this side, and you'd get 6 on the other side. So obviously that's not a possible answer. If you put in -1, you'd get -4 here and -6 here. If you put in 100, you'd get 400 and 600. Okay, so none of those things are going to work except for when I put in 0. The reason is that I can't multiply the same number by 4 and that same number by 6 and end up with the same value unless it's 0. So it's like saying that my row of multiplication facts, if I multiply by 4 and I multiply by 6, that those rows are the same. Then that can't be. So this is that situation where 0 would be equal x. So this is that one situation where you can get away with not showing me work if it's one we're doing on a quiz where I would be able to see that. All right, let's see here. And I think, okay, we'll just finish this last one out here. You know what? Actually, I'm going to tell you what the answer is and see if you guys can match it up. So let me see where I've got the answer to that fast. The wonders of time-lapsing. All right, so I paused that for a moment, and I went through and reminded myself that the answer to this one should be 0. So you can go through and check yourself on that one and see if you get that answer. If you don't agree and you're really feeling strongly about that, then send me a picture of your work and I'll see if you made a mistake or if I made the mistake. It can happen. I am human and make the mistakes as well. All right, so excuse me. I will have a quiz ready for you guys on Tuesday, and we will look a little bit further into our note packet then. So keep working in, Alex, and make sure that you are doing your SI time and your discussion board post if you haven't already. And I will put this all in an announcement on our classroom page as well to remind you of those things. Thank you.